Right, so question we're trying to answer is, what's the new height if this upper circle is rotated? So in other words, if we have a point that maybe started here from the top, but has been rotated around clockwise, has now moved to about there. So from a plan view, if we're looking down directly from the top, that point started here and has rotated around to here, 90 degrees away. So to figure out what that new height is, it would be useful to know what this distance is from this direct distance from here to here, because then what we can do is figure out the height if we knew the base of this right angle triangle. So if I draw in a radius here and one here, then we know the radii of this radius of the circle is 1 because the diameter is 2. So that's 1 and that's 1. So this base of or hypotenuse of the triangle or base of the other triangle is just going to be easy to calculate using Pythagoras. So it's just going to be square root of 2. From 1 squared plus 1 squared square rooted. So we know the base now is root 2. So if I just draw this triangle out here, it's now got a base of root 2. Its height we don't know, and this length we do know because it's 2, because it starts off as 2 and then gets rotated. I'm assuming it doesn't stretch or compress, depending on what material it is, and stays the same, then that'll be 2, and base is root 2. So similarly, using Pythagoras, we could figure out what this is. So if I call it x, then it's going to be that x squared plus root 2 squared is equal to 2 squared. Well, root 2 squared is just 2, so we've got x squared is equal to 4 take away 2, which is 2. So x is equal to root 2. So this height will actually be root 2. There you go.